John Fitzmaurice, and I'd like to share a mathematical model of a single shaft gas turbine. I picked it up from off the internet. It's an ASME paper by Bill Rowan, a guy who worked for GE back in the 80s. And I'll share it with you in another video. But um, for now, let me use my mouse and show you what I have. This represents the gas system. It's very fast, zero point 0.5. It represents the two valves and the sponginess in the gas system, because when you open the gas valve, it takes a minute for it to catch up. And in other words, it takes a minute to pump up the pipes to fill them full of gas. So then this is all in Laplace transforms, which I'm doing this in Scilab software. So in Scilab solves it. You don't have to, back in the old days, you had to punch every number in your calculator and plot it on a piece of paper. Those days are gone. And then this represents the turbine delay. There's another delay from the combustor. This is the torque calculation. These are where the software is collected, or the data is collected, excuse me. This is the summation of the torque. So I could input a load here. And so now I have my load. I come up here. So it's still torque. And then this constant is one I got from another website. Represents a frame 5. Well, all these represent a frame 5. And it converts the torque to speed. So as you can see, this is a very simplified uh, mathematical model. It doesn't have a breaker because speed doesn't change as soon as you close the breaker. So you should have load change. Well, that's not here. Then the speed comes out of here, comes around. It's compared to 100, and uh, then it goes to a PID, and the PID goes back to the gas system. So let's give it a run and see what we do. Now, I don't have there's no starting means in this, is there? So I just put fuel into it, and the turbine speed comes to 100%. So that's not a realistic model at all. But that's only the first 20 seconds. So you're going to see the fuel overshoot, and the speed, it goes to full speed in 20 seconds. Then after that, I'm going to have a 1% speed change, and you'll see a little bump down. Uh, this is an incomplete model. There's some things I have to change, but let's give it a shot and see what we can do. So there I am. Now I'm running it. Wow, torque summation, all these things. Now I'm going to open up speed window. So there, I overshot because in this math model, I'm just pouring a fuel to it, and it goes from 0 to 100% in 20 seconds. And there's my little bump in speed, where I programmed in 5 or a 1% change in speed set point at 60 seconds. So it's controlling pretty well. And I'm going to go into this in more detail and show you Bill Rowan's write up and some other things I found on the internet and some old files I had. So I'm, this is just a test video to see if I can, in fact, do the video.